Hi, welcome back. This is now section 8.1 in Math 0955. We are going to work with functions today. In the beginning, we just want to define what the heck is a function, and we begin with the idea of a relation. So what is a relation? And a relation is just a set of ordered pairs. So we relate one number to another number and take a whole bunch of them and put them in a set. So in question 1 over there, you're going to see a relation, which is, again, a set of ordered pairs. And they're going to want to know whether or not these things are a function. So a function, with regards to what we're this sort of setting, a function is a relation where each coordinate, the first number in the coordinate only goes to one other number. So here the first numbers are 2, then 5, then 8. And you can kind of make a little diagram here. So 2 goes to 2, 5 goes to 5, and 8 goes to 8. Okay. So long as 2 only goes to one number, and then 5 only goes to one number, and 8 only goes to one number, then we're good. Okay. We'll see an example of something that's not a function in a second. There's another definition we need here. It's domain, and the domain is just the x coordinates, basically. It's the numbers there that I drew in the circle on the left. Okay, so to write up the domain, we're going to use our curly brackets, and then just put the numbers into the curly brackets. So there's our domain. And the range are the y coordinates, basically, and then to write them up into the software, we'll have to use, let's see what they want. So question 1 is crud. Clicked on the wrong thing. Question 1 is this guy a function? Yeah, it is. Each x coordinate only goes to one y coordinate. The domain, and then they just want you to list the x values, 2, 5, and 8. Okay. And then the range are the y values, 2, 5, and 8 again. Okay, so no big deal. All right, so number 2, here's another relation given. And again, they want to know if the thing is a function. So here we go. It's 1, 5, 1, 8, 4, 5, and then 4, 8. Okay. So this one's not a function because this x coordinate 1 goes to two different places. And if we were to kind of draw another diagram, 1 goes to 5 and 1 is going to 8. So as soon as you see that split there, it's bad news. It's not going to be a function. Okay. So that would be kind of our little diagram. You don't need to draw the diagram. All you need to do is kind of scan it and see if there's any repeated x values. And that will tell you if it's a function or not. So this guy, no, it's not a function. Again, the number 1 in this x position is going to two different y values. It's going to 5, and it's also going to 8. So that makes it not a function, as well as 4. So 4 screws it up as well. 4 is going to 5, 4 is going to 8, so that's not good either. So it's definitely not a function. Over, check. And then again, they want the domain and range. For the domain, you may be tempted to write 1, 1, 4, 4, but all we're going to do is just write 1, 4. Okay, so you need not rewrite repeated values. And then the range is going to be 5, 8. So again, you don't need to write 5, 8, 5, 8. Just write 5, 8. Okay, so the domain is 1, 4. And if you put in an extra set of brackets like I just did, you're going to get it wrong. So they already have the brackets kind of drawn in there for you. I apologize. Okay, so there's the domain. Then the range is going to be 5, 8. Okay. So once you get the idea down, it's pretty clear as to whether or not a set of ordered pairs is a function. So in problem 3, this guy will be a function because if you look at the x-coordinates, none of those are repeated. So for every x-coordinate, there's only one associated y value. Okay. So 1 only goes to 1, 5 only goes to 5, -3 only goes to -3, and then -5 only goes to -5. So you'll say yes, because each ordered pair has a different first element. It's kind of another way you could think of that. And then you could go through the domain again. The domain is 1, 5, -3, -5. You don't need to put them in numerical order. You just sort of dump them into the set. And then likewise now, I guess the range is exactly the same, which is okay. You can have domain and range being the same. This guy is definitely not going to be a function because 1 is going to 3 different places. Okay, but anyways, the domain is just the number 1. So you can have just one element in your domain. And then the range is 7, 8, 9, the y values. Okay. And then it's not a function because you have 1 going to 3 different places. Okay. Now we're dealing with functional notation. So you could think of a function as kind of a magical machine. So the function's name is f. And then you're inputting x values into this machine, and you're getting out the y values, which are basically the result of putting x into the machine. So the way you write the output instead of y, you're going to put f of x. And it serves as a way to kind of record what's happening to your input variable. So the x value is the input variable, which they also call the independent variable. And then the output, the f of x, is called the dependent variable. Okay, so you can think of it as a machine. You're putting in these x values and you're getting out f of x values. Okay. It's really not any different than what you're kind of used to with the equations of lines. So for example, maybe you had y equals, so I thought for a second maybe I wasn't recording, I apologize. For example, if you had y equals 3x plus 2, the only difference now is we're replacing the y with f of x. Okay, so f of x is 3x plus 2, and it's going to allow us to kind of record what x value we're working with. So let's look at number 6, I guess. So number 6, our function f of, well, they're going to call it g. The name is g. So g of x is equal to 6x plus 3. And what they want you to do is basically substitute in particular x values. So g of 0 just means put 0 in for x. Okay, so wherever you see x, you're going to put 0. And then you use PEMDAS to simplify. So 6 times 0 is 0. And then 0 plus 3 is 3. What you did before that was similar would be the table of values, right? So before in your work, you may have an XY table. And here we just figured out the Y value given 0. So the output would be 3. And you can think of it as an ordered pair if you want. It would be the ordered pair 0, 3. Let's look at part B. They want you to put -4 in for x. So that's going to be 6 times -4 plus 3, which is -24 plus 3, which is -21. Okay, so you just go -21 here. Check it out. Yay. Part C, we have g of -3/2. So again, I'm plugging it in for x. I have -3/2 in for x, and then plus 3. You could rewrite 6 as 6 over 1, and then 2 goes in the 6 3 times, and 3 times -3 is -9 over 1 times 1 is 1. Then plus 3 is negative 6. And okay, and then part D, we have g of negative 2b, and that'll equal 6 times, and you're replacing x with negative 2b, and then plus 3. So for the first term, you can multiply out the 6 and the negative 2, that would be negative 12, and then you have the b plus 3, and that would be your answer. Okay? So you get negative 12b plus 3. Get it one of these times. Okay, and then you could put other linear functions into linear functions. So you could say g of b plus 4. And wherever you see the x, you're going to put b plus 4. Okay, so it's like substitution. When we did solving systems by substitution, you're going to go 6 times b plus 4. That's where the x would have been. So you're putting in there parentheses b plus 4. And then you're going to go plus 3. So we're going to have a distribution here, 6b plus 24 plus 3. And then simplify, and that's the best you could do. So 6b plus 27. So 6b plus 27. Okay, and then we have more of the same. Let's do one that's a little more complicated if we can find one. All right, so this guy's always kind of a nightmare type problem. Let's try it. This is number 9. So f of x is equal to negative x cubed minus x squared minus x plus 11. So part A, I want to substitute in 0 for x. So I'll have negative 0. Negative 0 is just 0 cubed minus 0 squared minus 0 plus 11. So those first 3 terms are just going to be 0. And then it's going to be 0 plus 11, which is 11. Okay. Plop in 11. Check answer. Yay. Try 3. So part B, f of 3. That's going to equal negative 3 cubed minus 3 squared minus 3 plus 11. So you're doing PEMDAS here, whether you know it or not. Negative 3 cubed is negative 3 times negative 3 times negative 3. There's 3 negatives, so that'll be negative. 3 cubed is 27. Minus 3 squared is 9. Minus 3, and then plus 11. So that'll be negative 36 minus 3 plus 11. That's negative 39 plus 11, which is negative 28. 28. Okay. F of negative 3. So here we have negative, and wherever I see x, I'm going to put parentheses negative 3. Okay, and then just slowly simplify. So in the first parentheses, you'll have negative negative 3. That's the same as 3. So you just end up with 3 cubed. Then minus negative 3 squared is negative 3 times negative 3. That'll be positive 9. And then negative negative 3 is plus 3, and then plus 11. And I'm still working with the exponent on the first one, so that's going to be 3 cubed is 27. And now I can start adding and subtracting from left to right. So I have 27 minus 9 is 18. 18 plus 3 is 21, and then plus 11 is 32. Finally, kind of more of a challenging one, f of 1 plus f of negative 1. So again, all I'm doing is substituting in wherever I see x, I'm going to put a 1. So I do one function at a time. So first I'm going to do this one. Okay. So plugging in 1, I get negative 1 cubed minus 1 squared minus 1 plus 11. So that's just that first f of 1. Okay. And then plus, now wherever I see x, I'm going to put a negative 1. So in particular, I'm going to use parentheses. So negative, normally it'd be x, but I'm going to put parentheses negative 1 in for x. Room there, smushing it in, I apologize. And so what I just written there is f of negative 1, right? So this thing right here is basically this thing right here. Okay, so negative 1 cubed is just negative 1, minus 1 squared is 1, minus 1 plus 11. Then plus, working on the inside of the parentheses there, you have a negative negative 1. That'll just be 1, and then cubed, minus negative 1 squared is negative 1 times negative 1 is positive 1. And then negative negative 1 is plus 1, and then plus 11. Right? We could do that 1 cubed is just 1, right? So I have negative 1 minus 1 plus 11 plus 1 cubed is 1 minus 1 plus 1 plus 11. That looks insane. So let's collect our terms together. Negative, there are 1, 2, 3, 4 negative 1s, so that would be negative 4. And then 1, 2, 1, so that's plus 2. And then plus 22. Right? So that would be 24 minus 4, which is just 20. Yay. Okay. In this problem, they're working with functions in a different representation as a table, basically. So number 10, how does this work? It's basically just the xy table up here. Okay, so if your function was y equals 6x plus 3, you could make a table out of that by just populating in some x values. So if I put in 1, it would be 6 times 1 plus 3, which would be 9. If you plug in 2, that would be 6 times 2 plus 3, 12 is 15. It's just they've now replaced the y with an f of x, right? So now we're using f of x for this functional notation instead. And you can build a chart this way. In this problem, in these problems, they're not going to give you the function itself. They just give you the chart. Okay, and then they want you to answer some questions about certain things. So you have a table. I'll move this over so you can see it. You have x and then f of x. Okay, so the x value is negative 4, negative 2, 0, 2, 4. And then on the f of x, the outputs, negative 8, negative 1, 6, 13, and 20. And then they ask questions, and you just use the chart to answer them. So f of negative 4 is from this row here. So the output for negative 4 is negative 8. You just look under the f of x column. Okay. So the output for f of 2 is right here in this row. That will be 13. And then finally, they want to know kind of the reverse question. For what values of x is f of x equal to 6? So you go to the second column where you see 6, and then look at that row. And in this case, the corresponding x value is 0. Let's make sure those are all right. Negative 8. Okay. 13, and then 0. So sometimes there's more than one for that last answer, like h of which h of x is equal to 2. Well, negative 2 and positive 2. Right, there's more than one answer for number 11 in that last question. Oh, and then these questions, these are important later on for mathematical modeling, especially if you're working in digital problems like with electricity, basically. So you'll see these piecewise functions. It just gives you an extra way of modeling mathematical objects. So anyways, you have two pieces basically. I believe they're called piecewise functions. So you have 2x plus 9 is the first piece, and you use that if the input value, if the x value is less than 0. So if it's a negative number, you use the equation or the formula 2x plus 9. Then if you have then you use the formula 7x plus 2 if your x values are greater than or equal to 0. So if they're positive values or if they're equal to 0. Okay. So then we go through, okay, so I need to know what is f of negative 6. So negative 6 is less than 0. Okay. So you use the first piece. You use the function 2x plus 9. So wherever you see x, you're going to put negative 6. And so that will be negative 12 plus 9. And that will be negative 3. Okay, part B, we have f of 0. So this time, if you try to say, is 0 less than 0? No, it's not. 0 is equal to 0. So it's not going to go into that first piece. It's the second piece, right? 0 is greater than or equal to 0. So you use the 7x plus 2. So I'm going to go 7 times x, which is now 0, plus 2. That'll be 0 plus 2, which is equal to 2. Part C, I have f of 8. So here, 8 is not less than 0. So we don't use that piece. 8 is actually greater than or equal to 0, so we use the 7x plus 2. So I go 7 times 8 plus 2, 5, 6, 7, 8, right? 56. And then plus 2, and that would be 5, 8. Okay, let's type some of these in, make sure they're right. Negative 3. F of 0 is dos. No dose. F of 8, we just did was 58. And then finally, one of these other guys. So let's see. F of negative 100 plus f of 100. So negative 100 is less than 0. That's true. So we use the first piece there. So in this first function, it's going to be the 2x plus 9. And then 100 is greater than or equal to 0. So we use the second piece, the 7x plus 2 on that one. Okay. So in the first one, I have 2 times negative 100 plus 9. And then plus 7 times 100 plus 2. Right, so that would be negative 200 plus 9 plus 700 plus 2. Adding together, it looks like 511. Let's see if we got it. 511. Enter. Excellent. Oh, and then we have some story problems. So they want you to represent the data as a relation. Basically, just write it as a set of ordered pairs. And in particular, they want you to write a set of 4 ordered pairs in which each of the least corrupt countries corresponds to a corruption rating. So the corrupt countries are countries A, B, C, D, E, F, G, H. The least corrupt ones are A, B, C, D. And then they have corruption ratings. So I guess the higher rating, the less corrupt. Okay. Okay, so they want you to write a set of 4 ordered pairs in which each of the least corrupt countries represents a corruption or corresponds to a corruption rating. Each ordered pair should be in the form country and then corruption rating. Okay, so you're just going to write the first yellow bar is country A, so you put that first, and then the rating is 9.7. And then B, comma 9.3. and I was reading these numbers off the chart. C, comma 9.3 again, and then D, comma 9.5. So we can type those in real quick. Hopefully, better use a capital A. 7, let's see, is B, comma 9.3, comma parentheses C, comma 9.3, comma parentheses D, comma 9.5 parentheses. Okay. Is this thing a function? Well, yeah, each x coordinate only goes to one y coordinate. So A only goes to one number, B only goes one place. So yes, so each corruption rating corresponds to exactly one country. Or rather, we should say each of the x is the country. So each country corresponds to only one corruption rating. Now they want you to flip it, right? They want you to put the corruption rating first and then the country. So we could just kind of cheat and look off of what we already written and reverse the coordinates. Okay, so we have 9.7, comma A, comma 9.3, comma B. I keep putting spaces in there. I don't mean to. I don't think it matters if you put a space or not, but 9.3. I don't want to find out and have to rewrite it. So, comma D, comma 9.5, comma D. Sorry, 9.5, comma D. Okay. Is this guy a function? And no, it's not, because 9.3 is going to two different places. So one corruption rating is corresponding to at least to more than one country. So that part B. And then yay, and then is that it? Am I done? Yeah, I guess I'm done. Okay, so as usual, I hope that helps, and have a good time studying, and I'll see you next time.